What we're talking about today is finding an equation of a quadratic. And to find the different equation of a quadratic, there are many different ways we can do this. If you recall, there are several different equations for a quadratic that we've talked about and displayed. And the key concept is when we're finding these is we're going to use these different types of equations. I'm going to go to a different page. So for the different quadratic equations, we have ax squared plus bx plus c. That is a basic one where obviously a can't equal 0. All right, now with this one, this is the general form of a quadratic, and we don't really use this one very often when we want to find a quadratic equation. Other ones that are quadratics that are very useful when we're finding equations are ones that look like this. All right, this one is standard or graphing form. All right, standard or transformational form. Transform form from this. From here, we know that h and k are the vertex. And we know that a is this value, the multiple, all right, that we need to solve for. Okay, so this is the multiple. All right, the multiplier also gives us if it's going up or down. Now, another one that we can use is where we have x-intercept form. And I'll write it like this. And where we have right here, b can't equal 0. And we know that b and c are the zeros, or x-intercepts, / x-intercepts of our function. So any one of these forms we can use of a quad. All right? And the key thing is trying to identify when we use which ones. Well, it all depends on what type of problem we have. So, for example, if you were given a graph of some sort of quadratic, and in this quadratic function, they give you v being the vertex, all right, and we have another point on this graph. All right, so if we were to graph this, all right, so this is just a point. To sketch this graph, we would have a vertex which would be located at -2, 2, 1, 2, 3, 4, 5, and we would plot this point. We would go down to 0, 9, 0, 9, so 0, 9, and 5, 6, 7, 9, and we have this point right here. And what's happening is this graph is going to look something like this. Now, to find out what this is going to be, this equation, we're going to figure out, well, what type of equation would be best suited for this. While looking at our graphs, we notice that we're given a vertex and a point. So since this is standard form, requires a vertex and a point, what we can do is just simply figure out what the transformed graph would be. Well, since we're moving over to the left 2, it would be x plus 2, quantity squared, moving up 5 from there. So we plug our values in there. We have our a value, and now we can solve for our equation. How do we solve for our rest of the equation? We have to solve for a. How do we solve for a? Well, we plug in our point. So plug in point. Plug in point. All right. So to do that, we're going to take this value right here. We're going to plug in 9 in for our y value. We have a. We're going to plug in 0 in for our x. Plus 2, that's quantity squared, plus 5. All right. And now what we have right here is going to be 4a plus 5 equals 9. Subtract to the other side, we have 4 equals 4a, and a is going to equal 1. All right. So we plug that value in here. I plug the 1, and our final answer then would just simply be that. If you wanted to FOIL this through, you can put it in general form. All right, or we can just leave it like that because that is a quadratic equation. All right, well, if we look at another one, I'm going to put this up, all right, and bring this over here so we just focus on this. We're going to find another equation, and in here what we're given are 2 points, all right, if you notice that we're giving -3 and 0 and 1, 0, and then another point which is -1, 4. Well, in this one, if I graph this out, and I would suggest graphing it if you're not sure. All right, we got 1, 0 right there. So we have -3, 0, and then 1, 0. Then we have another point, which is going to be -1 and 4. 1, 2, 3, 4. All right. Well, with this, we're going to figure out what this graph is going to look like, and we know it's going to go through these points. This might be the vertex, might not be. If we're not sure, we might realize that, hey, all right, our equation for this has a vertex. We're going to find it. Or what we can do is, looking back at our other problems, other equation, is that given the zeros, which we do have, we can actually use this, a factored form. So I'm going to actually create this factored form. There's another way you could do this, but I'm going to create the factored form because give me the zeros. So I'm going to have y equals a, because I don't know what that is, x plus 3, that's one of my zeros. And I'm going to have x minus 1, because that's my other 0. All right, just so you know. See that? Here, and here, and then here, and here. Okay? So, from there, okay, and identifying those, we can now take this and now solve for our a value. How do we solve for a? Well, once again, we plug in our point. Okay, so take this point and plug it in. So we have 4 equals a. We have -1 plus 3. We have -1 minus 1. Simplify a little bit, and what you notice is that, hey, we have a times 2 times -2 equals 4, and a is going to equal -1. All right, so we have this right here. We'll plug in a -1 in there. Place that a value, and that's going to equal -1. And that is our equation we could use. We could FOIL this through and get our general equation. All right, another way we could do this is we could actually find our vertex if we wanted to. Okay, in order to find our vertex, we know that the vertex is directly in the middle between these two zeros. So we could go 1 plus -3 and then divide by 2 to find the x value of our vertex. Because once again, it's right in the middle. When we have that, you might be able to see it right away, but it's at -1. Oh, so it appears that I didn't know this in the beginning, but this point at -1 is actually our vertex as well. Okay, so what we have then is we could also write this equation as y equals a times x plus 1 squared, all right, plus 4. Okay, solve for our a value, plug in a point other than the point you used. So I'll plug in 1, 0. So we have 0 equals a, we'll have 1 plus 1 squared plus 4. And from here, we have 2, 4a, takes -4, and a once again is equal to -1. Plug that back in there. And we have the negative. So we know that's reflected over the x-axis. All right, but that's the same equation as this one. All right. If you simplify it into standard or general form, that means foiling it through, we'll get our same answer. Okay. So what we went through just now is we found the equations of 2 different quadratics, all right, given points on the graph. The key thing is identify what points you are given and try to pick which equation would be best fit. All right, either a standard one graph or x-intercept graph, but all of these can be turned into the general graph by simply foiling and simplifying these basic problems. Okay, so both of these can be generated into this. All right, final one if you simplify. All right, so I hope that helps out. Good luck with the rest of your homework or the rest of learning about quadratics.